here we are, and this is the video for page 178, and we're looking for 1 through 45, every other odd. Multiples of 4, 10 plus 1. So number 1, I'll take y equals 2 e to the x, and we'll differentiate that, just trying to find dy dx. So dy dx equals 2 e to the x still, because 2 stays, e to the x stays, and then we have the derivative of x, which is just 1, which we don't need to write. Number 5, we have y equals e to the 2x over 3. So dy dx. Here's our rule. We're going to have e to the 2x over 3, then times the derivative of the 2x over 3, which is just 2/3 x, which is 2/3. That's 2/3 e to the 2x over 3. Number 9, y equals e to the radical x. So dy dx is going to be e to the radical x. The derivative of x to the 1/2, which this is x to the 1/2, is going to be 1/2 x to the negative 1/2. So dy dx equals, let's see, how about e to the radical x all over 2 the radical x. Right, because this stayed on top, the 1/2 got broken up, so it was 1 over 2. X to the 1/2 went in the bottom, which is x to the, or radical x rather. Oops, not 11, 13. Alright, so how about y equals 3 to the cosecant of x. Alright, so we use our rule and we find that dy dx. Rule we're going to use is the quotient formula. I should probably write down these formulas. So dy dx of e to the u is e to the u du dx, and ddx is u, and ddx of a to the u is going to be a to the u natural log of a du dx. So those are our two formulas that we're going to apply rampantly and at every turn. Now, we already have several times. Here we go. So we've got a to the u, 3 cosecant of x, times the natural log of 3, compensate for that a, then du dx. Derivative of cosecant is, which one is that? Negative cosecant x, or cotangent of x. There's not a whole lot of cleaning up you can do. It's kind of messy. That's all right. So that would be negative 3 to the cosecant of x times the natural log of 3 times the cosecant of x cotangent of x. We can throw some parentheses around there so we don't confuse everything. That's all she wrote. And let's see, 13, 4, 17. 17, y equals the natural log of 1 over x. Natural log formula is just the derivative with respect to x of the natural log of u is equal to 1 over u du dx. So this is going to be slightly confusing, but I think we'll figure it out. U is 1 over x. So when we differentiate the natural log of 1 over x, natural log of anything is going to be 1 over what's ever underneath that pen. It's 1 over x times the derivative of 1 over x. So 1 over x is just x to the negative 1. And the derivative of x to the negative 1 is negative x to the negative 2. Right. So we'll keep that negative x to the negative 2 over here. Now we just have to clean it up a touch. 1 over x, just x. And then this is times negative x to the negative 2, which is 1 over x squared. So this x and that one can cancel. So this winds up being negative 1 over x, or negative x to the negative 1. Either one will do just fine. We can squeeze 21 on the same page here. So 21, y equals log base 4 of x squared. We could take this 2 and put it out front. There'd be nothing wrong with that. In fact, yeah, let's do them both. So let's do this by doing 2 log base 4 of x. So we'll do both of these problems, realizing that they're the same problem, but in one we'll have to use the chain rule a little more effectively than the other. So we'll use a formula. Here was our formula with the natural log. Formula where we have the regular log is d dx of the log base a of u is equal to 1 over the natural log of a times u, or u natural log of a, and then still du dx. So that's our formula. Just add a natural log of a in there, same way we did up in this one. Compensate. We change the base formula. So we take a derivative, dy dx equals 1 over natural log of 4, then u, which is x squared, and the derivative of u, which is 2x. And so that'll give us 2x over natural log of 4x squared, and this x and that squared can cancel, and give us 2 over x natural log of 4. So we get it the same way over here. So dy dx will be 2 times 1 over natural log of 4 times u times the derivative of u, which was just 1. That's pretty clear that those two are the same. dy dx equals 2 over natural log of 4 times x. Well, x natural log of 4. Otherwise it looks kind of like 4x. But they're plainly equal. And 25. We need to do y equals the natural log of 2 times the log base 2 of x. Alright. And alright, so although we have multiplication here, this is constant, so we don't have to worry about it. We can just stick it on the front. So the natural log of 2 still out front. Log base 2 of x is going to be 1 over x times the natural log of 2 times 1. And these two natural logs will cancel, so that's kind of nice. So dy dx, those go out. So it's going to be 1 over x. We do have to remember here that x is in the bit here. Means we got to put a continued on it. X can't be negative is not going to be negative to begin with. So that means that x is plainly going to be greater than 0. That is when these are useful. just double check that that's not also the case in the previous ones. I may have forgotten to do that. Come to think of it. Let's see here. Let's see. Restrictions. No, I could take e to about anything. Same with 5, 9. Displaying that e to the x. X can't be negative up here. But nor can it be in either of these. So the restriction is kind of moot. Again here, the restrictions on cosecant are gonna follow into there. 17. So x certainly can't be 0 here, but nor will it be at the end. But x does have to be, 1 over x has to be greater than 0, which means that x has to be greater than 0. So let's put that caveat on there. So here was our final response, but this is x does need to be strictly greater than 0. Come up with that log. 21. X squared is real nice here because that makes it automatically non-negative, and the fact that x can't be 0 is also down there. So we're good to go on this. Good. And we'll come back and do the rest of the problems in just a moment.